Suppose you are working for a company that is interested in research about all existing homes in Lake County. And you're tasked with coming up with the research. For example, they'd like to know what is the average of all home values in Lake County. Also, they're interested in, for example, the number of bedrooms, how old they are, etc. So what are you going to do if you do not have access to the database? One thing you could do is go to a website and find the prices of the homes that are being sold today and average those, or prices at which they were sold for the past 2 weeks or so.
So I went to redfin.com and I searched for homes that were recently sold in Lake County, and it yielded 187 results. So one thing we can do here is average the prices of these 187 homes. Now, of course, this is not the true average. The true average would be the average of all homes, the prices of all homes in Lake County, not just the ones that were recently sold. But we're hoping that the average of these 187 will be a decent estimate of the true average.
What I just showed you illustrates two basic concepts of statistics. The first is the population. The population is the collection of all objects we are trying to study. We're trying to study the average of all prices of all homes in Lake County. So the population in our study is all homes in Lake County. However, often the population is inaccessible or too large to study. So we take a subset of the population. We call it a sample. So in our example, the sample is the 187 homes that were recently sold. So instead of having to find the average of all home values in Lake County, the hope is that we can get a decent estimate by finding the average of the homes in our sample instead. So let's go ahead and find that average.
I was able to download the file from redfin.com containing those 187 homes, and it has a wealth of great information we can use. So it has address, cities, zip code, price, number of bedrooms, number of bathrooms, square footage, year built, price per square feet, homeowners association per month, etc. So first of all, let's change the formatting a little bit. You can see that some of these columns are too small to fit in the entire phrase. So for example, this, what we call cell, contains the address of this particular house, but it doesn't fit in this column. So we can resize the column by doing this: drag or double click. Another thing we can do to make this look nicer is these prices are not formatted correctly. They don't have the dollar sign and they don't have a comma. And I want to format this for all of these. So I can select all of these. Okay, right click, choose format cells, then choose currency, and change the number of decimal places to 0. Okay, and that looks much nicer. Now, what I want to do is to find an estimate of all prices of all homes, all values, right? All home values in Lake County. And we're going to estimate that by averaging the values in this sample. So we want to average all of these numbers. So first notice that the prices of these homes go from column H, row 2, and they go down to the last one, which is H188. So instead of adding all 187 numbers and dividing by 187 to find the average, we can use what we call built-in functions in Excel. So we do that by selecting an empty cell and then enter the equal sign. As soon as you enter the equal sign, Excel recognizes that you want to access one of the built-in functions. In this case, the built-in function we want to access is the average. So start typing average, and you see that it will show you a list of potential functions that you might be interested in. So double click on average. Now Excel is expecting you to enter the numbers that you want to average. So you can enter the number separated by comma, but also you can just enter the location of the numbers. So in this case, remember the location was from H2 all the way to H188. So you enter a colon symbol and H188. Close parenthesis, press enter. And it gives you the average.
But 318,631 is not the true average. It's only the average of the sample. So this leads to the following two basic concepts in statistics: parameter and statistic. A parameter is a number that describes the population. So in our example, the true average of all home prices, of all home values, that is our parameter. A statistic is a corresponding number that describes the sample. So in our example, the average prices in the sample is a statistic. And this we found to be 318,631, and we're only hoping, we don't know for sure, that the parameter is approximately the same.
Let's go back to our database of our sample of 187 homes. We have all of these different columns which reflect the different types of variable that we can consider for our database. So there's a variable city, there's a variable price, for example. And the actual values under the columns, they are the actual data. So the data is simply the possible values of the variables. What I want you to think here is we cannot treat the column H, the column for price, the same way we would treat the column for city. Because, for example, I can sort the database from lowest to largest price, and that would actually carry some meaning. But we cannot do that for city. We could order them alphabetically, but it doesn't really carry the same meaning. By the way, if you want to sort this, you just select the entire column like this, and then click on sort, and you can say sort from smallest to largest, say expand selection, and it will sort all of these from smallest to largest. Okay, but back to our discussion. So we want to come up with a way to categorize the data. Not just because some we can sort and others we can't, but also it will be important when we graph these, because the way we graph price will be different from the way we graph city. So city is an example of what we call qualitative data, because they qualify the homes into different cities. Price is an example of what we call quantitative data, because these are quantities. But within quantitative data, we want to separate them into two kinds. One is quantities that you get by measuring, and others are the ones that you get by counting. So number of bedrooms, for example, is what we call discrete, because you count them. Whereas price per square feet is an example of what we call continuous, because you measure them.
So in summary, data can fall into three categories: qualitative, quantitative discrete, and quantitative continuous. Examples of qualitative would be city, zip code. Even though zip code are numbers, they're just labels. Examples of quantitative discrete would be number of bedrooms, number of bathrooms, and an example of quantitative continuous is price per square feet. For our sample to be truly representative of the population, when we randomly select the sample, we want it to be unbiased. So that's what it means to be random. For that to work, we first need an integer generator, a random integer generator, and our calculator has one. So make sure you learn how to use it. The first method to do a random selection for our sample is simple random sampling. And basically the way it goes is that, let's suppose that you have 1,000 elements in your population, and so you go to your random integer generator and ask it to produce, say for example, 30 random integers. That's if you want a sample of 30 numbers. And whatever the calculator spits out, those will be in your sample. So if the calculator spits out a number 2 first, then that 2 is in your sample, and then if the next one is 17, then 17 is in your sample, and so forth. The next method is the stratified method. In the stratified method, we divide the population into groups, into subgroups, and sometimes those subgroups are naturally formed. So in our example of homes in Lake County, we can divide the homes into their cities or villages. And then we pick a proportionate amount randomly from each subgroup. And what I mean by proportionate amount is, if say Grace Lake has double the amount from Gurnee, let's say Grace Lake has 20,000 homes and Gurnee only has 10,000, then if we pick say 4 at random from Gurnee, then we should pick 8 at random from Grace Lake. The next method is the cluster method. In the cluster method, we again divide the population into subgroups, and then we pick basically entire groups at random. For example, let's say that you're a quality control manager in some kind of factory that produces these boxes with items. So the items in the boxes are the product of the factory, and you'd like to sample some of these items to check for quality. The stratified method wouldn't work so well in this case, simply because it's very inconvenient. You would have to open every single box if you wanted to use the stratified method. The cluster method is instead you pick entire box and you check the entire box. So let's say that there's 8 boxes, so we label them 1, 2, 3, 4, 5, 6, 7, 8. And let's say the calculator, you go to your calculator and you ask it to produce say 2 numbers out of these 8. So it produces, let's say, number 2, then the entire subgroup 2 is in your sample, and let's say it produces the number 7. So then this entire subgroup is in your sample. That means that the actual items that are inside each of these boxes, those are your sample. And then the last sampling method is the systematic method. The systematic method simply is the following. You again label the elements, say 1 to 1,000. And you ask the integer generator to produce a starting point. So let's say it produced the number 3 as the starting point. And then you count every n to be in your sample. Now n here has to be a predetermined n. So let's say that n we predetermined it to be 5. Then that means that from the starting point chosen by the calculator, you choose every 5 elements. So if the 3 is your first element, the next in your sample will be the 8, and then the next one will be 13, then the next one will be 18, and so forth.